This is a Research Infrastructure Services instructional video.
Hello, and welcome to the Open On Demand workshop. In this video, we're going to go over what Open On Demand is, how you connect to it, what you can do within Open On Demand, and how it can enable your research using the RIS Compute Platform. So what is Open On Demand? According to their website, Open On Demand is an intuitive, innovative, and interactive interface to remote computing resources. So what does that exactly mean? Well, that means that Open On Demand, or OOD, it's a web-based browser interface that connects to compute resources. In this case, in our particular case, the RIS Compute Platform. So any of the jobs that you would do or start within OOD launch on the compute platform in the background. So what does this mean for users then in this case? Well, users can use a web base to access the RIS Compute Platform, which means theoretically anywhere you have a web browser, you can utilize our services, at least in some aspect. You can use any number of supported applications or potentially incorporate your own through this. We're still working on a process of getting all of this finalized. And users can navigate the RIS Compute Platform and their computing needs in a GUI instead of via the command line, which is the more traditional high-performance computing method of running jobs and doing analysis. So the first thing we need to do, if you haven't done it before, if this is your first time using the RIS Compute Platform, is before we get into Open On Demand, you need to make sure you log in via the command line once, at least once. What this does is it sets up your account so that you can then access things as expected and as necessary. So there's a bunch of home directory, environment variables, and all that gets set up that first time you log in, and so we need to make sure we're able to do that. So if we go to our terminal here, so if you're using a Mac like I'm using for this demonstration for this seminar, you can use the terminal. It's built in, it's right there available. Linux computers have a terminal built into them as well, typically. And if you are using Windows, you can utilize software. We recommend two free software, that's MOBA Xterm or PuTTY. You can also use PowerShell within Windows, at least Windows 10 and up, to connect via to compute via the command line. So to connect to compute, the command is simply SSH, and then you type your WSL key. So in this case, mine is Ellen, and then it's at compute1 -client, and then dash, and now we have a number, and that number is related to which login client you are using, and currently we have 4 login clients. So you could type 1, 2, 3, or 4 here. I'm going to go ahead and use 4. It's just the one I like to use, as it seems to be used not as much as some of the others. Then once you have your number, it's period or dot ris dot wsl.edu. And once you have all that typed in, you hit enter. It's going to prompt you for a password. This is your WSL key password. This is your single sign-on for WashU password, as well as your WSL key is what's used to connect to compute. So I just type in my password, and since I already have my home directory and all of my settings set up because I've logged in before, you're not going to see that here. But if it's your first time, you'll see some extra words and verbiage that's displayed to the screen telling you kind of what's happening. That's letting you know that things have been set up correctly. And now you can connect to OOD. So in this case, we're going to go ahead, I'm just going to exit back out because I don't need to stay logged in since I'm using OOD. You don't need to stay logged in via the command line to use OOD. Once you've done the one login, if you don't want to, you don't have to go back to the command line unless software you want to use requires it. So in this case, we'll go back to our documentation here, and you can find our OOD documentation and this video on our documentation website, which is docs.ris.wsel.edu. In this case, getting started, what we need to do here is we need to go to the Compute OOD website. And so that address is listed here. It's also a link, so you can click on it, but it's https://compute1-ood-1.ris.wsel.edu. So if I go to this tab, I already have that all typed in here, and if I hit enter, it's going to take me, it's going to do some login stuff. It might take a little bit of time for this to do it. Not too long, but just a little bit depending on usage and compute, availability. Also might depend on the internet you're using and how fast your browser can talk to the compute platform. So now you can see after a little bit of time here, we have the main page up and on display, and so we just have our logo, and then it says open up on demand provides an integrated single access point for all your HPC resources, and that's true. So this menu up here, if we click open on demand, it'll just take us to the main page. Over here you can see I'm logged in as myself. I can log out. You want to make sure you're logged in as your own user. It typically will do that once you've logged in the first time. And then there's other menus here that we can go over. So files, you can just see your home directory. Go to your home directory. You can look at your active jobs or go into the job composer. We'll get into the job composer and active jobs a little bit later. Clusters, so this is if you want to connect to compute via the command line, but you don't necessarily have a terminal available for you, you can use OOD to do that as well through our serial access here. And so now this next menu is our biggest one, is the most important one, as it's the apps that are available through OOD currently. We're working to expand this and increase the number of applications we have available through OOD so that we can help support more users and hopefully streamline how they work with the compute platform. Right now what we have is we have the Jupyter Notebook, we have MATLAB, we have RStudio, we have Relion 3, and we have Stata. We also have this Compute RIS desktop. What this does, it gives you an GUI-based desktop access to the compute platform. And then the final of these menus is My Interactive Sessions, and we'll get into that a little bit later here once we have an active job going. So as an example for this particular case, we're going to go ahead and use RStudio. So if I click on RStudio here, what this is going to take me to is a page where I can create an RStudio job. There's a bunch of fields that you simply can click and enter your text manually, or they might have a drop-down menu that you select from. And so the first field is our mounts, and this is your storage mount. So just like on the compute platform, if we're doing command line work, we can mount any storage or scratch space that we want here. As you can see, mine automatically fills because I've used OOD before to do some testing and to troubleshoot. And so it's automatically filled with my own personal active space allocation. as a note here, just like when you run a job via the command line, home is auto-mounted. You don't necessarily need to mount your home directory. Then here, at least for RStudio, we have a field for version. This may change depending on the requirements of a software. It may be there, it may not be. In this case, we have 2 versions available. We have 4.02 and 4.03. Hopefully in the future, we'll be able to add more versions through OOD so that you can have more accessibility to different RStudio requirements. All right, the next field is the job group. All jobs on the compute platform default to a job group. The default job group is kind of transparent. You don't have to. You don't necessarily see it when you're using the command line. You can create your own, and that is just a way to help regulate your jobs. In this case, we have a default OOD job group that's available, that's auto-filled here. Then the next is user group. This is a drop-down menu that you can select from the different user groups you're part of. As you see, I'm part of multiple. So you can select which ones you want. Which user group you want, just like if you're using the command line. The queue, you can select the queue to general interactive here, or you can use one of your own queues. So if you have a condo, you can use your condo here. Then you can select the amount of memory, and these, the user group, the job group, the queue, the memory, the number of hours, the GPUs to allocate if the software allows that, the number of processors. All of these are the same fields through all of your different applications or different software as they are necessary. So we'll use the general interactive queue here. For memory, this is the amount of memory. This can go up quite high. It defaults to 2. Given this is an example, we'll just go ahead and use the default of 2. The number of hours, I'm not going to spend hours on this utilizing RStudio, interacting with it, since this is just an example, so we'll leave our number of hours at 1. The number of hours you can keep the notebook running or your job running is whatever you set it at. The default, if you're using the general interactive queue, again, is the 24 hours. That's just the default for the general interactive queue. GPUs to allocate, I'm not going to be using any GPUs. You can have 1 to, should be a limit of 4, really, as there's up to 4 GPUs on a host. Then the number of processors here, we're going to leave it at 1. I don't need more than that for my example. And then the font size is default. You can select medium, large, or small. So that's just the font size that's displayed on the GUI after you've launched the job and connected to the job. So now that we have all of our fields selected and inputs we want to use, we go ahead and click our launch button here. And now we wait a moment. Now that we've hit launch on that, it's taken us to our interactive sessions, which I mentioned before. And this is where you can see any jobs that you have started, are waiting, or are running in OOD. These are only jobs that you've done through OOD. If you have jobs that you've done through the command line, through other means, you won't see them here through this. And so you can see it's starting up. This process does take a little bit of time, but you can see that we have when it was created, the timestamp for when it was created, the time used. You also see that we are given a session ID. That's important. You can go back to that. And then over here, we don't want to do this yet, as we want to get our job launched so we can look at go into what that looks like. But we can delete a job. So if you're done with a job, you click delete, it'll log out, quit the job for you, and release those resources that you were using back into the queue so that other people can utilize them. And it's important that once you finish with a session, since Open On Demand is typically used for interactive type jobs and sessions, once that's done, you'll want to make sure you delete out of that job so that you aren't taking up resources without using them. So now if we go to clusters here, this is the shell access. We'll go ahead and look at that while we wait for that job to complete. So now that opens up a new window with our shell access. It's going to prompt you for your password again. So you hit enter, and now you can see that I am, well, it's through OOD, I am on the compute platform here. You can see this. And I should have access to all of what I would normally have if I connected through the normal command line methods of using the terminal and logging in and all that. So if I type ls, I can see my home directory. If I want, I can change directory into my storage directory and see what's available there and all that. Now if I hit exit, it says my connection has been terminated, so I'll go ahead and exit back out of that. We'll go back over to here. And now we can see that my RStudio that I started up before is now running. Another thing to mention that I didn't before is if we look here, we are giving a job ID number. This is important when we're on compute, as you can see that through the a terminal. So we'll go back and do that here in just a little bit. But for now, it shows us, now we have a host that we're connected through, and it gives us a button down here that says connect to RStudio server. So if I click that button, it's going to again open up another window connecting me to RStudio. So in this case, you can see here, it's opening up RStudio. I have an error simply because I have quit out of RStudio before without saving some things, but that's not necessarily going to pop up for you, and it's not an issue or an error in any form that's going to affect your work. So now you can see I have access to RStudio, the software I decided to use in this particular case for this example, and I can do things within RStudio like you would normally expect. So like in this case, I'll just do an example here. There. So now I've created a variable of x and it's equal to 5 plus 5. So you can see up here, just using software, it's got that variable listed and the value for it, because I did make it 5 plus 5, so it was 10. So now we can just use your software as you want. So here, y is x plus 6, and so you can see it's 16 because x is 10, so we're just using our software. When you want to quit out of this, all you have to do is close the browser window. Your job will still run as long as you still, there's you're within your time frame you set of how many hours you want it to run, or you haven't deleted it out. Your job will still run and you can reconnect to it. So if I hit connect again, it'll reconnect me in. And as you can see, it saves, because the job's still running, it didn't quit anything out, it saved the state that I was in. So if you have to potentially close out for a period of time while your job's still running and come back to it, you can without losing anything. So now let's say close back out, I'm done. What I need to do now is go ahead and hit the delete button, and what this will do is we'll quit out of our job. But before I do that, I want to go back to looking at the shell and looking at the job number. So we can see that the job number in this particular case is 270633. So now if I go back to my shell access and I type in my password, if I typed correctly, I did. Via the command line, you don't need to know this for OOD. It's just an example so that you can see it. See what jobs you have running, you type B jobs. And if I type that, we can see that I have a job running. It's on the host compute OOD because I'm running it through Open On Demand, and the job ID is 270633, which matches back here. So we'll go ahead and leave this terminal open just so we can show what's going on. But if I hit delete now, it's going to ask me to confirm. So you don't have to worry about accidentally quitting out of a job because you've clicked that delete button. It's going to pop up a prompt of, are you sure you want to delete this, so that you can't, accidentally delete that. And in this case, I want to confirm. And now it says I have no active sessions, which is what we expected because I deleted it and I didn't have any other jobs running. If we go back here and I type that bjobs command again, we can see that the job's gone here as well, and it's no longer there. It's asking me if I want to leave in this case. Yes, I don't need to save anything. There wasn't anything there, so we can leave that safely. In terms of jobs, again, this is our active jobs page that I'm on now. You can go to Job Composer. So what this is it allows you to compose a job based and create the job like you potentially would on the command line, but using more prompts. And it's going to tell you where it's going to save the job and what the job script name is, all of this. And it's going to show us what that job is here if we click that. Didn't mean to click that quite yet, but it's kind of showing us what we're creating for a job here. So if we go back, down here is where the script is that you're for your job. And so this is a B subscript. If you go to our documentation, we do have a bit of documentation on B subscripts here. In this case, it's very basic. It's using Ubuntu to say hello world. What we can change is through here, B sub job script, we can again change the amount of memory we want, the amount of processors we want, and we can change the script, what the script is actually going to do here. So we'll go ahead and open it in the editor, which is where we were before. You can see that I can edit all of this. So now if I want to change my Docker image, I can. So focal. Without changing the any of the settings, this will default to the default parameters for memory and CPUs, which is 2 CPUs, 4 gigabytes of memory, just like the command line. So we can change that here with the options. So I just add another B sub line. Oops, if I can make sure we type this correctly. It's the # or hashtag B sub, all capitalized here. And then the option in the case of processors -N. So we'll up this to 8. We'll say we're just, for this particular job, we're going to use 8. Now we need to add another option of memory. So in this case, -R. This one's a bit more complex. R usage mem equals 32 GB. So this allows us to set the memory to 32 gigabytes. So now we're going to use 8 processors with 32 gigabytes. Again, we're just using Ubuntu Focal. It's just a specific, one of the specific Docker images from Ubuntu using the Focal operating system. So if I go ahead and up here and click save, I've now edited this, it saved it. So I can close out of the editor, and if I come back here, it's now updated in the main job.sh. It's updated what the script contains. And so I can open open terminal. I can open directory where this is, but over here, this is more important. We can edit job files. We have job options. We can open the terminal again. We can start with a new job here, and you can create templates or starting a job from a specified path, or start a new job from a selected job. But once we have that job set up, we can go ahead and submit. As you can see here, I've ran one before, but if we hit submit, it's going to submit this job, and it's queued. We can see here. So this puts a job in the general queue as a batch job, so you're not going to interact with it, but you can monitor that type of job here. And you see again, it's giving me a job ID, which if I were to go in through the terminal, through the command line, I could see that job there as well. It's queued. I don't really need this job to run or anything. It wasn't doing anything but printing out hello world. And so instead of waiting for this, here you'll see its status. It's queued, which is the pending status if you're looking at the command line. If it's running, you'll see running, and when it's done, it'll say it's completed. In this case, I'm just going to delete my job, which you can do here. So if I click delete again, it's going to ask me, are you sure? It's going to give me a prompt, so I can't accidentally delete a job. So I'll go ahead and click OK, because I didn't want it. So now it gives me some steps to create a job if I want, but I have no jobs available. I don't have any templates because I didn't use a previous job. And so that's the job composer. So I'm going to go ahead and close back out of this and go back to the other. And then there's the file. So if I click here, it's going to open up a GUI-based directory of my home directory. And so I can go through this. As you can see, I have an on-demand directory and then a bunch of files. I don't have a lot here. But I can download these files, I can edit them, and what this will do is if you want to edit a file, it'll open it up into an editor, just like before. So we can see it's opened it up into this editor. I can move or rename them, I can copy them out, I can view them instead of going through the editor, and I can over here can delete them. And if we do delete, it's going to again prompt me. Everything that's going to do something more permanent is unless you're editing a file directly and you click save button, it's going to prompt you to make sure you do want to do what you're doing. It's asking me if I really want to delete this. In this particular case, I don't want to delete this. I don't want to take that file out of my home directory right now. So that's the home directory that you can access through here. We've done the shell access, the jobs, we've done the active jobs, the job composer. Now the last thing here is this compute RIS desktop. Instead of a specific software, this just will give me a prompt, again, to create a job through this system. So we'll just go ahead and leave everything as is. I don't need more than any of the defaults. If I click launch, we'll go ahead, and it's going to queue up the job again for us. We're going to have to wait. Again, as the little message states there, it's if you're pending, if you're sitting in the queue like that, the amount of time it takes is dependent on how much resources you requested. So the more CPUs, the more memory you request, the higher the chance of having to sit in the queue, simply because you are requesting a higher amount of resources on the server, and they may not necessarily be immediately available, and so you may have to wait until they become available to you. Again, here now we have the job started for me. You saw it switch over there. We can determine the image quality that we want to see, the amount of compression here. on this particular job. So I'm just going to put it up to max just to demonstrate. And then again, like the RStudio, down here I have a launch button because we're going into a GUI for the software. So if I click launch, you can see it takes me into a desktop based terminal. And in this case, it's using Linux base, but there's still a lot of things that are point and click because it is a GUI, even though it has this command line up. So if we click over here, we have some no VNC options. It has clipboard, full screen settings. I can disconnect out. If I right click, this gives me my menu option in this version of Linux. So we can see our shells, our system, Windows managers, configuration styles. We can adjust things, change different things, all of that. But it gives us a desktop to work from. But again, we're working via command line here. So if I type ls, again, I'm in my home directory. We see those same files available as when we were logged in through other places. So now if I disconnect here, I'm not connected. If I go back here, it hasn't deleted. It just disconnected me out before I closed that window. And so it's still available. If I want to hit refresh, I can refresh. This automatically refreshes every so often to show us what jobs are available, what's still running, all of that. But you can manually refresh as well. Since we don't need this anymore, I'll go ahead and delete out. And it'll take it a moment. Now my job's successfully deleted and there's no current active jobs. If I were to run multiple, I would see the multiple available here. I'm not going to necessarily do that as an example here. But I do believe we have gone over everything at this point. So I'd like to thank you for watching this video and for using RIS services. I hope this was educational for you and you are able to do your analysis utilizing our compute platform. Thank you.